Alright, welcome back for another fun math lecture. Here in this video we are still going to continue, or we're going to talk about absolute value inequalities. So we're going to look at the couple of rules that you have to follow and then do just a couple quick examples. An absolute value inequality is solved a little bit differently than you would in an equation. So we have two rules and one major concept that we have to follow. So that first major concept is that your absolute value must be isolated and must be positive. Okay? And so what that essentially means is that your absolute value can't have anything attached to it. So that part is very similar to an equation. But when we're talking about that the absolute has to have a positive solution, what we're meaning is that the basic rule of absolute value states that if you have an absolute value, it doesn't matter what the sign inside your absolute value is, when you evaluate, it comes out positive. And this is something that happens always. No ifs, ands, or buts. It's always. So we have two rules that we have to follow. The first is an and rule. The second is an or rule. So an and rule says if your absolute value is less than your number or some constant, then you're going to follow the and rule, which says you're going to rewrite your absolute value into the and form, where you have the negative through to the positive. If your absolute value is positive, then you're going to follow the or rule, which says you're going to break it up into x being less than the negative a, or the negative constant, or it being greater than the positive. Okay? So we need to solve these inequalities. First thing we need to note is that my candy wrapper has a wrapper. And so the only way that I can get to my candy bar or my ooey gooey center is I have to peel that wrapper away. So the first thing that I have to do here is I have to divide both sides by that negative 3. In doing so, there's a couple things that are happening here. First, we have to apply your negative rule. Your negative rule says that when you multiply or divide by a negative, you have to flip the sign. So when I divide on this left-hand side, it goes away, leaves me with the absolute value. I have to flip my sign according to my rule, so I'm going to flip it so it goes the other direction. And then I have a negative 6 divided by negative 3 gives me a positive 2. Now this next thing that we have to do is we have to look at which rule are we going to follow. Okay? So here what you can see is that this is going to follow the absolute value is less than a. So this means we have an and situation. To do that says we need to identify a few pieces. We need to identify the x and we need to identify the a. And the reason for that is so that we know what gets plugged in, because our rule says negative a less than x less than a. So when we look at this, my x term is talking about the gooey center. So here my center is going to be 4 minus x. The a term is talking about my constant over here, which is 2. So I have to plug into my equation here. So my equation says that I have negative 2 is less than my x, which in this case was 4 minus x, is less than the positive. Okay? So this is the hardest part, being able to navigate your absolute value and then get it into its proper form so that you can then simply solve your inequations. And once you get down to this part, this is everything that you do when you solve inequalities, which means we need to isolate the x variable, you need to graph your inequality, and you need to state its interval. So, in order to isolate it, the first thing that we need to do here is we need to subtract this 4 from all sides. And in doing so, negative 2 minus 4 is a negative 6. My sign remains the same because I'm not multiplying or dividing. I'm subtracting here. So this is a negative x. My sign remains the same. And then I have 2 minus 4 is a negative 2. Now the last thing I need to do is I am dividing everything by a negative 1. Because I'm dividing, that tells me that now I have to flip my signs. So here this becomes 6. My sign is going to flip, so it's going to come the other direction. Leaves me with x in the middle. Again, flip my sign, and leaves me with a positive 2. So what does this give me? This right here is my inequality. And with that inequality, I now have to do my graph, and I have to do my interval. So to do my graph says that I need to draw my number line, so I'm going to go ahead and do that. And when I draw number lines, I like to put in my negative infinity and the positive infinity, put 0 in the middle. And then I have to look at what do I have here. Well, I have the numbers 2 and the number 6. And now I need to look at my inequality signs. Both of them are inequalities. Neither one of them have an equal, so that means parentheses. And because this is an and situation, it means my parentheses are going to face each other. So I have that x is going to be everything less than 6 but greater than 2. So that means shade in here in the middle. And last, I can write my interval. So remember, your interval needs to match your graph. So I'm going to open a parenthesis at 2. I'm going to travel to 6, and I'm going to close my parenthesis. So that is your first example here. It's an example of an and situation. Let's take a look at this next one. Now, the biggest thing you need to remember about all of these is do not judge the book by its cover. You have to read the content inside. And so here, when you first look at it, it appears as if this equation would be an and situation. But what you have to take note is that my box of chocolates has a wrapper. And in order to get to it, I need to undo my wrapper. So the first thing I have to do is I need to remove my wrapper so that I can actually get to my juicy center and see if I have an or an and situation. So to do that, I need to subtract my 4 from both sides. In doing so, leaves me with my absolute value, 3 minus 2y. And in this case, I still have my greater than or equal to. 6 minus 4 is 2. Now if you look at it, my absolute value is completely isolated and by itself. Thus, I can go ahead and identify which actual situation I have going for me. And in this case, the situation that I have going for me happens to be an OR situation. And so when we're talking about following the rules, we're talking about doing that. We have to identify what exactly is going on here. And so when we look at this, we are going to follow the absolute value is greater than my A term. Again, we need to be able to identify X, and we need to be able to identify A, so that we can follow the rule X is less than negative A, or X is greater than the positive A. In identifying this, remember X is the juicy center inside, so this is going to be 3 minus 2y, and A is going to be the constant. In this case, it's a 2. So I can go ahead and input these things into my formula. So I have that X is less than negative A, or X is greater than A. So substitute my information. I have 3 minus 2y is less than a negative 2, or 3 minus 2y is greater than the positive 2. Now if you remember the ORs, OR says you need to solve both equations simultaneously, so we're going to go ahead and do just that. I need to subtract 3 from both sides, so this leaves me with a negative 2y is less than negative 2 minus 3 is a negative 5. I can go ahead and continue to solve. I need to divide everything by negative 2. So y, because I'm dividing, says I have to flip my sign. So I'm going to go ahead and flip my sign. And then I'm going to have 5 over 2. Now the very last thing that I need to keep a close eye on is I started this problem where I had greater than or equal to. So at the very end here, I need to remember if I started with a greater than or equal to, I need to finish with greater than or equal to. I'm going to go ahead and input my OR just so that I don't forget it, and I need to solve the other side. Again, I need to subtract 3 from both sides. So I have negative 2y is greater than 2 minus 3 is a negative 1. Divide everything by negative 2, and I have that y is now less than 1/2. And again, because I started with the equals to, I need to add the equals to back in. That means I can now create my number line. So I have negative infinity to positive infinity. I'm going to go ahead and input my 0. And then I have 2 fractions. I've got the fraction 1/2, and I have the fraction 5/2. So my first one says that y is going to be greater than or equal to 5/2, so that means a bracket. So I'm going to bracket around my 5/2, and I'm going to go off to the positive. And then my other one says I'm less than or equal to 1/2, so again I'm going to bracket, and I'm going to shoot off down the other side. And I'm going to make my intervals look like my graph. So my first piece here starts at negative infinity, travels all the way up to 1/2 before it has a problem. I'm then going to union, which signifies the space here in the middle. I then have to start at 5/2, and I'm going to travel all the way through to positive infinity and close it off. And that is an example of doing an OR situation. The last quick example I wanted to go over is actually a favorite of mine. It's an example that gives you an appearance of one thing and then ends up showing you something else in the very end, which I find to be very fascinating. Of course, I am a math nerd, so I find a lot of math fascinating. Hopefully by the end of some of my lectures you will start to find math fascinating as well. Or you'll just start to think that I'm a crazy woman in my home talking to myself, which is fine too, because right now with COVID-19 that's what I'm doing. Alright, so to get back on track, I again have an absolute value here. And just like before, my absolute value chocolate box has a wrapper, and I have to unwrap my wrapper in order to get to the chocolate inside. And if you can't tell by now, I love eating chocolate. So the first thing I need to do is I need to subtract out my 7 from both sides. So 2 minus 7 is going to give me -5. My sign stays the same because I have not multiplied or divided, and then I have my absolute value of 6w minus 2. Now, here is where I like to say you can leave your absolute value in this form, or you can rewrite by just simply shifting it around so that your absolute value is on the left and your constant is on the right. You're going to get the same answer either way. It just depends on how you like to look at it. So if you're somebody who needs to shift it around so you can see it better, that's perfectly fine. I personally like to rewrite it because I like using something that matches the rule. And if you remember, both of our rules have this absolute value here on the left-hand side and the constant on the right. So I like to rewrite to make it match so that I don't accidentally assign the wrong rule to the wrong problem. So here, if we look at it, what you should be able to tell is that we are going to follow the OR absolute value, because my absolute value resembles the absolute value of x greater than a. And this means that the rule that we're going to use is that x is less than -a, or x is greater than the positive. So with this, again, we need to look at what is x, what was a, so that we know how to plug things in. When we're talking about x, x is going to be, again, this ooey gooey yummy inside here, which is 6w minus 2. A is going to be your crunchy outside, so here we've got our constant at -5. So this being said, a lot of students would say, oh, hold up, wait a second, my a is negative, so I can't do this problem. Well, that's not quite so true. Let's just take a look and see where it goes. So the first thing we need to do is we need to rewrite our absolute value into our rule. Okay, so it is an OR rule. So my x was the 6w minus 2. So I have 6w minus 2. And this is going to be less than the negative of your a. And so here my a is a -5. So notice I'm putting that in my parentheses. And then I've got OR, and I need to do the other. My x is the 6w minus 2. I then have to input my sign, and I have to use the positive. So my a term was a -5. So this one kind of gets your brain doing the hokey pokey, which is fine. You just need to follow the math and see where it takes you, following all of the rules that you have. So with this, the first thing I want to do is over here on this left-hand side, I want to take care of this negative thing. So I have 6w minus 2 is less than 5. I need to solve for w. Add 2 to both sides, and I have 6w is less than 7. Divide everything by 6, and w is less than 7 over 6. I'm going to put in my handy dandy OR, and then I'm going to work the other side. I still need to add 2 to both sides, so 6w is greater than -3. I then have to divide everything by 6, so I have w is greater than -1/2. Why? Because 3 over 6 reduces to 1/2. So now I've got my two terms. So at this point I'm feeling pretty good. So I need to go ahead and I need to set up my number line. So I'm going to set up my line here. I've got the negative infinity to the positive infinity. I'm going to input my 0. And then I'm going to start on my one side. And so here I've got 7 over 6. So I'm going to input my fraction. So I've got 7 over 6. And in this case, I am looking at all of my terms that are less than 7 over 6. So I'm going to use a parenthesis, and then I'm going to go ahead and fill in my number line. Okay, so notice it comes all the way down. And now I need to do the other side. My other side is that w is greater than negative 1/2. So I'm going to input my negative 1/2. And then I'm going to go ahead and I'm going to input my terms. And so I'm looking at being greater. So my parenthesis here is going to face the other direction. And I'm going to shade this way. So, whoa, that definitely looks different. So remember how I've said that your interval has to match your graph. So take a look at what actually happened here. My actual graph is going from negative infinity all the way through to the positive infinity, which means this is a special case. So my special case here is the case of all real numbers. My interval goes from negative to positive infinity. Okay. So like I said, this example here specifically happens to be one of my favorites because even though it is an OR rule and follows your OR situation, it encompasses the entire number line, which means it is that special all real number case and has an interval that goes from negative to positive infinity. So that about wraps up what we need to do with absolute value inequalities. If you have any questions, please don't hesitate to let me know. I would love to answer any questions you may have on the subject. And if anything else, I will see you next time.